In this class, we start looking at the basics of how to install the software needed, in particular Visual Studio. And then I'll go into a simple example of how to redirect input and output so that it's easier to, in the future, to do testing and debugging of the software. I'll go through a set of slides regarding the installation, but do not worry, we'll also publish a separate video that will walk through also more in detail the process. As a reminder, coming up for next week, the coming week, we're gonna have as a first homework, it's kind of a warming up. We will simply require to download the form for academic misconduct from the computer science department, and we'll post the link and so on, and everybody should sign it to indicate abiding to the rules, and then going through the process of putting that in a zip file and uploading into the system. And that's meant to accomplish two goals. One is to make sure people are aware of the rule, and it's known from psychological studies when you sign, even if you know that you're doing that for their purpose, but if you sign your name under the rules, you're less likely to go down the cheating route. So that will be good for everybody. But also to make sure that you start gaining experience in submitting the files in the proper zip folder, so that later on when you submit source code for the programming homeworks, that will not create any issue. So let's go to the installation of Visual Studio. Again, this is a set of static slides. We'll publish also a video so that we'll go through click by click in the process, but it's good to see what's important. So once you download from Canvas the Visual Studio environment, so we already put there the executable to make sure that everybody has the same version. In particular, that would be Visual Studio 2017. The Visual Studio environment has several components, in fact a fairly large set of components, and we will start working on the desktop development for C++. So that's the part that you want to check, and that will automatically add a set of components. There are additional ones that in principle one could add, but for now we just need the foundational part. And then as soon as the system installed, you can run Visual Studio and look at creating a new project. Again, we'll have a video with more details, but you have the typical file, new project, build what's called a solution, and that's the Visual Studio environment that contains potentially a set of projects, and each project a set of files. In our class, effectively, we always have only one project in one solution. And then once that's created, you have a few options, and you want to create an empty project. Once you have the proper environment, this is how a project look like, and you want to make sure you add a source file where you can write the C++ code, and there again you get a set of possible templates, and you want to have a file of type .cpp. We'll see later in the class what the .h or header files are going to be used for, but for now you want a CPP file, and then cut and paste the content of any piece of code. We'll publish one simple example just for context, and that will allow to start working. Now, to set the environment in a way that is concurrent to how we analyze the homework submitted and the level of errors and warnings. You want to make sure that you do the same type of settings that we propose, and so you show the error list. You want to build a configuration for 64-bit. I'm pretty sure everybody has a 64-bit machine, and once you have the environment, you can build that particular solution. So you create the executable from the source code. And so to get proper feedback from the compiler, there are a few things you have to do. You right-click on the project, not the solution, the project, so that you pull out the properties, and then you can set up the warning level. So we set up the highest warning level so that you are pushed to build the cleanest possible code. If you cannot build the code without any warning at this level, once you start using things more advanced, it becomes quickly hopeless. To keep everything standard, we want to disable language extensions. So you just need to select yes from the perspective. We pick ISO 17 as the standard of the language. As you can imagine, over time, although there is a standard, there is actually many versions of that standard. So it's important that we agree on what version of the standard we're working with. And then we work through the console. For those initial applications, we don't want to deal with the user interface aspects. For that, actually, we will wait for using Python. And then you can see how to run the code, debugging, setting, breakpoints, and so on, so that you can actually run through the system and see how that works. In particular, you can run the code inside the debugger. So F5 is the function and normally is associated, but there is this triangle. You can decide whether you run it with the debugger or not. And finally, so I'll run an example. This is the part you want to pay attention more, is that how to make sure that we redirect the input and the output, because you can be asked to type things from the console and then things get printed. And why that can be convenient for a very small example, as you build larger and larger solution, it's important that you can automate the process for testing. And so instead of typing things manually, you want to do what is called redirecting the input and the output. And I'll go through how to do it. Let's first see the concept. You'd look at the in the debugging window aspect here. Then there is the command line arguments. Normally that's empty, meaning that the program just starts without any input. But then you do this less than input greater than output. It means this less than is really meant to be an arrow. So the input goes into the program and the output goes from the program to that file. And I'll just go through a couple of examples just to give a sense how that works. And so that will allow to create those files. In particular, in this case, we're going to talk about input and output. And so instead of having to type manually the things you want to do, you can just have that pre-created and add that as part of your source code directly. And then you have full control of what's going on without having to do any manual intervention to the application. You can also run the environment. I'll just show that as an example from the console. So I'll show how to run things out of the command prompt in a second. And that's just a possibility if you want to do things outside of the system. And it's good for everybody to understand that you're not kind of prisoner of Visual Studio. You can use that to build the software and so on, but then at the end, the executable will run outside of that system. So just to go back to how to look at things here in practice, here I have a simple solution called print name and class. So here is the set of properties that we can adjust. Let me go back to the slides. And so we're talking about setting warning levels and things like that. So for example, here in the configuration, you go to language, and so here we can look at C++ is a language, and you can say disable language extension. So often the default is no. You want to make sure you put it into a yes, and then you apply your change. Going back here, language standard. So here you see you have several options. There is the 14 standard. There is a generic default, and then you want to make sure you pick the one that you want. And so here we go for 17. Again, so that we agree to what things are going to be used for. And then we look at inside, you see the linker tab. So here we have the separate tab, look at system. And so here you want to make sure, you see you could do native, Windows, various way, or not set. In this case, we want to use the console. So now we have a simple program. And again, in another video, we'll go very much in detail. So I'll just blaze through a little bit just to give a sense. We define a few variables. We say, oh, print your name, which is read in a string. And then we create a set of print statement that say welcome to the class. So the routine in this case is to go and build the solution. And so here, let me see, let's actually start by cleaning the solution. And so here we are for now in, let's put it in debug mode, and then we build the solution. You see that the system goes through, succeeded in building the solution, and you see there are no errors in the process. And so here, again, I'll go through quickly. There will be more examples. You have the code that you can run, so you can just run it through. A console comes up. Say, please enter your name. My name is Valerio. And then I type enter, and you say, hello, Valerio, welcome to, and the set of classes that we're taking now. To make it easy, we'll stop and not close the console, but I can click on the space. Now, if I want to run this process over and over again, it's not convenient to every time that I do the execution, I have to go in and type something, right? And then I do it again, and I have to type something. Especially think about if you have to type many, like a set of addresses from a database and things like that. You really don't want to rely on typing things by hand, potentially making mistakes and so on. So as we were showing here in the slides, you want to go into the debugger and say, okay, I'm going to read from standard input directly from a file. So this time let's say, okay, I'm going to go into release mode. Let's see, do properties. Let's see, go back. Debugging command arguments. So we go into debugging command arguments. And let's say I do smaller than input for now dot txt. So if you run it and we have this problem that it cannot find input or output redirection files. So we can go back to the project properties. So having set input txt, we have now created the file. So let's go back to, so this is, sorry, yeah, this is the folder where we have the code. This is the file that we have. So here we want to introduce a new text file called input txt. Ideally, actually, what we can do is add that to the project itself, but we can also edit that we can edit obviously outside of Visual Studio. Let's see, now we created an empty file. Here I can put my name, Valerio, and some new lines, so it's being created. So at this point, the file is there. Now it gets executed. Notice that exit with code 0. It's a good sign. That's the way it should be. And so things went through quickly. We had the file being read, and now we didn't get a chance to see the result. So what we want to do is then add the output redirection. So what normally would show, in fact already did, but we didn't get to see because it was too fast. So we create the output redirection. So at this point, we go back to our code, run it again. And so let's go and look at the directory where we have the file. And now we see that a new file, output txt, has appeared. Let's edit that outside of Visual Studio. And you see you have enter, please enter your name. The name here is actually typed by the other file, so it's you don't see it, but then you see hello Valerio, and then welcome, the welcome message to the project itself. So in principle we can also add the output file to the project. This is kind of just to have everything directly there, and so we can see input. Let's say instead of Valerio I'm gonna put Bob as a name, so we could rerun this, and now the output file has changed. You say hello Bob, and so as you can see that by changing one, and we can set another name, run the code again, and the output file, you see hello Charlie. So this gives a sense that if I want to have multiple input instead of typing by hands, I can just run it immediately. That will show up in the file, and that will help in the debugging process, but also that will be the way we evaluate the homework output. And so it's important to learn how to set it up. So again, here you go, you do properties, command line arguments, smaller than input, greater than output, and that's the way to do it. Thank you, bye-bye.